Hi there. So we're going to go over arrays some more because arrays are really, really important. And if you understand arrays and you sort of nailed them and if you got them cold, then you're going to find most of the other stuff we do this year very manageable. If you do not understand arrays, if you're weak on sort of how they work, then you're going to struggle. So I really want to spend some more time on arrays so that you have them, you understand them very solidly. So first, I'm going to go through some stuff, adding some code here, and then ask you to add some additional methods to this. So the first thing we're going to do is I'm going to use the random object. So I'm just going to import java.util.random. So we have access to that. And up here in the fields, we might as well declare. We're going to declare a random object, and down in the constructor, we'll say r equals new random. So we've got a random object ready to use. Cool. Now, next what we're going to do is create a sort of that shortcut, call this list one form of doing an array with the braces. So 1, 3, 5, 8, 9. That's good enough. Doesn't matter. All right, so now we've created an array with 5 elements. Their positions are 0 through 4. So 1, 3, 5, 8, 9. Can you imagine that? And the length of this array is 5, even though the uppermost index is 4. All right, so let's next add a method that will print public void print array. Now we're going to do this so that we can pass in any array of integers. So we'll just do int, and here we'll call it list. Right? And so this method gets in an array of integers, and within the method, that array is called list. It actually gets in a reference to an array of integers. Let's just make sure everybody's clear on this. So here's our array. So we actually out here have a pointer to list one, points to this guy. And when we eventually call print array, what we'll pass in is this reference, right? The address of this array in memory, which is represented here graphically by the arrow. Right? The arrow always represents an address. And so we're giving the array here reference access to the same list, right? Cool. Like that. All right, let's get going here. So what do we need here? We need a for loop. Almost always in a print method, use a for loop because you're going to go through all the elements of the array, usually. And we use our old friend LCV equals 0, LCV less than the length of the array, which we can get by the array's length value. So list dot length, and then we're going to keep going as long as, oh sorry, we're going to increment LCV by 1. Okay, and we don't need any braces here because we're only going to do one thing here. Right? What we're going to do, we're going to output what's in the array position. So starting off with list sub LCV. And that is all we're doing. Just printing all those elements one at a time, right? We're just going through and printing them. And now we need to call this method. So we'll call it from the constructor just to make things easy. So print array, and which array are we going to print? We're going to print list1. So we'll send list1 in, and it should print it. And let's compile that, and cool, it actually compiled, and now we'll make a new one. And there it printed out the array 13589. Excellent. Okay. So let's go back to here. I meant to do print ln or println. Okay, but it worked. Nice. Now just to be clear, right, if I add some more elements here, 56, compile that up, do this again, right? And it all works because, right, I'm using list.length, and that automatically adjusts as the length of the list is adjusted, is altered up here, okay? Much better always to use variables of some kind. That's why I'll often use max, which I define up in the fields or in the constructor, rather than constants. Because if I had done this as 5 here, when I changed the length of this list, I would have also had to go back and change this to, what is this, 8? Okay, so always use variables when you can. Now, let's do something else here. We're going to shuffle the array elements. I'm doing this because I want you to see how a swap is done. I'll just call this shuffle array. And we'll take in any array of integers, and I'll just call it some list here for the heck of it, just so that you know that it doesn't have to be called list. And I know within here that I'm going to need a couple of integer variables. So one is temp, where I'll hold a value that I temporarily pull out of the array, and one is random position, which is I'll use the random number to generate a random position within the array, the random number generator. So, so I've got those. Now I need a loop. Same loop as up here. I just copy that. It's cool. I'm going through the entire array. Now what I'm going to do is generate that random number position. Now these are random object, which we made up here. Next int. And what do I want this random value to be? I want it to be within the range of the, let's go back to our old array. Within the range of our array. Right? It has to be within, generate a number between 0 and 4. So if I do list length, that's going to work just fine because the next int method does not include the value that you supply here as the top of the range. Right? So that's going to generate a number between 0 and 4, which is exactly what I want. And now what I'm going to do is pull out into this temporary variable the value at SUMList sub LCV. So that's the 0 position the first time, and it pulls it out. Why is it pulling it out? Because I'm going to move something in there from random position. So I'm going to say SUMList sub LCV equals SUMList sub random position, right? And so if I hadn't pulled out what was at SUMList sub LCV and stored it in temp, I would have lost it when I moved the value at random position into the LCV position. Okay? Now what I want to do is put temp into that SUMList random position location equals temp. And that's it. If I haven't made a mistake, and if I have, the compiler will tell me in just a second. I need one more right brace. And I like to get these lined up. It just makes it nice and clear. Okay, so this should shuffle the array. Now, in order to test that, we've got to call it. So shuffle array, and what array are we shuffling? We only got one, list one, so we're going to send list one in there. Again, what we're really sending in is the address of list one. So that shuffle array has the same address. It's just called some list down here, and they're working on the same list. And we'll compile that. And okay, some list. And again, some list. Next, copied. Okay, cool. That's good. And we'll make a new array, and that didn't do. What did we miss here? Oh, after I called shuffle array, I didn't call the print method again to see if it actually did shuffle. Now let's see if we've got it. And boom, it made it, and look at that. How beautiful. There's the original list down through there, and then it shuffled it. The one just happened to stay where it was, but all the others have, well, the 9 didn't move around either. But you know, let's make another one and see if, yeah, see this one, they all got moved around. So it is working. It's shuffling them around. Excellent. Okay. Good. So let's add one other thing. Let's make another array up here. Make this one slightly differently. List 2. So up here we've declared the array. But we haven't actually, we've declared an array variable, really, list 2, but we haven't made the array like we did here by just putting the numbers between the braces. So what we'll do is down here in the constructor, actually make the array, or instantiate the array as it's sometimes called. List2 equals new int, new array of integers, and we'll make 100 of them. Go big. Okay, and that's all good. So now we've got a new array, list2. Now, we could print it by just calling print array and passing in list2. And if we did that, what it would print out is all zeros, because when a new integer array is created, just like when a new integer variable is created, it contains zeros by default. So, but I want to do something else. So let's add a method here called public void, and we'll do fill array with random values. And again, we're going to have an integer array passed in. We'll call it this time, we'll call it list again. Just to keep things easy. Okay, so we're going to pass in this list2 array and fill it up with random values. So let's start with this loop, and that's cool. And we actually only need one line here, which is nice, so we don't need braces. So what we're going to do is say list sub LCV equals R, that's our random object, next int, and we'll ask for a big integer, something between 0 and 999. And that's all that's going to do. And I hate that. I wish that would go right lined up like that. Anyway, okay, cool. So let's just compile that to make sure we're good. Good. Now, we've got to actually call it from up here, right? So let's temporarily comment out this stuff. I don't know if you guys know this, but you can, from the edit menu, you can do comment, and it does that for a whole block of code. That's kind of nice. So what we're going to do now is we're going to call fill array with random values. I'll just copy that, save some time. And what we're going to pass in, we're going to pass in list2, right? And we want to know whether it actually did anything. So we'll pull that print out of there, and we'll change that to list2. So remember I said before it would have been all zeros. You can test this yourselves if you don't believe me, but let's compile that and see if it works. Oh, look at that. Okay, so lots and lots of random numbers between 0 and 999. Here's a little trick which I like to do. In our print here, just so we have the position as well as the value at the position. What we'll do is we'll print the LCV, the position, plus, and then inside quotation marks we'll put like colon, space, plus. Oops, what's that F there? Plus. Cool. So position of the array, and then what's at that position, the element at that position. So let's compile that, and I'll just do this again. And, nice. Okay, so 0 position is 136, 1 position all the way down to, move that up, the 99 position as 159. Okay, cool. And oh, just for the heck of it, let's, what was it, the 0 position? 136. So, because we've written our code nicely here, we can call shuffle array with, well, you know, it's going to generate new random values anyway. But actually, we can do it. We can do it. We'll first print whatever random values it generates, and then we'll shuffle it, and then we'll print it again. And we want this all to be with list2. Okay? And so we'll make a new one. And, all right, so here's our first list. Starts with 198. This is when we generate it. And here's our second list after we've shuffled it, 416. And we should find 198 in here somewhere because, there it is, because we're shuffling it, right? We're not regenerating it. So, see how easy that was because of the way we set this up? Right? We're always using the name of the array.length to get the length. And so if we come with a different array, everything with a different length, everything still works. So, hope that helps. I went through that quickly, but just some more information about arrays. Last thoughts, quick last thoughts. Some things to be aware of. Right, most most programming errors with arrays occur because you go one too far with a loop variable. You'll see this when you do sorting next week, and you start to get into sorting. So you go a little bit too far on either side. And because sometimes you're processing your array from the end down to the beginning, but in either case, if you're going from the beginning to end or the end to the beginning, sometimes if you're not careful, you'll go one too far and get a subscript out of bounds error. And I guess the other thing to always remember is that arrays are passed by address. Really, really important, right? So list 2 would point to this array if this was that array that had 100 elements made down here, right? And when we pass list 2 into any of these methods, they also have what they have is the address of that array, right? So always passing addresses when we deal with objects, and arrays are objects. Cool, thanks.